This is Flowline Chronicles, stories of water, people, and the future we share. India's great rivers have never been just channels of water. They are the foundations upon which civilizations rose, carrying not only flow but memory, movement, and meaning. Among them, the Ganga stands apart. From the Himalayas to the plains, its waters shape land, cities, and lives. Long before modern infrastructure arrived, and long after it must adapt. Today, as India's riverfronts evolve, engineering faces a deeper question. How do we design infrastructure that respects water, ground, and tradition all at once? The Ganga is not a static river. It is a living system, responding to snowmelt, monsoon pulses, tributary inflows, and sediment movement. In its middle reaches, the river slows, widens, and spreads. Floodplains emerge not as anomalies, but as natural extensions of the river itself. Historically, these floodplains absorbed excess flow, replenished soil, and sustained agriculture. But as cities expanded closer to the river's edge, this balance began to change. Engineering interventions narrowed channels, fixed embankments, and constrained a river that was never meant to stay still. Beneath the cities of the Middle Ganga lies young land, alluvial soils deposited over thousands of years. These soils are fertile, but they are also dynamic. Riverbanks erode, channels migrate, and ground stability shifts with every flood season. In places like Varanasi, Prayagraj, and upstream stretches near Ayodhya, infrastructure rests on terrain shaped more by water than by rock. When floods arrive, the challenge is not only managing water levels, it is managing the ground itself. Engineering in such landscapes demands foresight, understanding erosion patterns, sediment behavior, and long-term river movement, not just immediate protection. Along the Ganga, cities do not merely face the river, they return to it. Sacred riverfronts like Varanasi and Prayagraj are shaped by centuries of ritual, seasonal gatherings, and human flow that follows the rhythm of the river itself. These are not occasional events. They are predictable, recurring patterns. More recently, new urban focus has emerged around Ayodhya, extending the cultural geography of the river corridor. For engineers, this adds a unique layer of responsibility. Riverfronts here are not only hydraulic interfaces, they are social, cultural, and temporal spaces. Designing for such cities means accommodating water movement, ground behavior, and human congregation simultaneously. Traditional flood control focused on resisting the river, raising embankments, straightening channels, and isolating floodplains. But modern river engineering is beginning to shift perspective. Instead of control, the focus turns to continuity. Floodwater can be guided, redistributed, and temporarily stored through refurbished channels and adaptive riverfront zones. Urban infrastructure can be designed to work with seasonal variability, allowing controlled inundation where appropriate and resilience where protection is essential. This creates a water loop where excess flows are not treated as threats, but as design parameters. The river remains dynamic, the ground remains respected, and cities remain connected. The future of India's riverfronts will not be defined by monuments alone. It will be defined by how intelligently we integrate engineering with natural systems and human traditions. In river basins like the Ganga, the question is not whether floods will occur, but whether our infrastructure is ready to adapt. When engineering acknowledges the river's freedom, the ground's nature, and society's rhythm, resilience becomes possible. This is not about preserving the past or resisting change. It is about designing continuity so rivers can flow, cities can thrive, and traditions can endure. Rivers carry water. Ground carries infrastructure. People carry tradition. Engineering must carry all three. This is Flowline Chronicles, where every story reminds us of the delicate balance that keeps us alive.